Welcome back to JVM Internals Crashcasts. I'm your host, Sheila, and today we're diving into a fundamental concept of memory management in the Java virtual machine, stack versus heap. Joining me as always is our JVM expert, Victor. Hey Victor, ready to unstack some knowledge today?
Hey Sheila. Absolutely, I'm all heaped up and ready to go. It's great to be back for another episode.
Before we dive in, let's set the stage for our listeners. We're currently in our JVM Novice season, exploring the fundamentals. We've covered the introduction to JVM and core concepts in previous episodes. Now, we're in the Memory Management Basics chapter. Today's topic, stack versus heap, is crucial for understanding how Java manages memory. Victor, would you agree that this is a cornerstone concept?
Absolutely, Sheila. Understanding the difference between stack and heap is fundamental, not just for Java, but for many programming languages. It's like knowing the difference between your pocket change and your bank account in the world of memory management.
That's a great analogy, Victor. Now, before we get into the nitty-gritty, I'd like to pose a quiz question to our listeners. Here it goes. In a Java program, where is the variable int x r5 stored, and where is the object new array list stored? Think about it, and we'll reveal the answer at the end of the episode.
Ooh, that's a tricky one, Sheila. It really gets to the heart of our topic today. I like how it makes listeners think about different types of data and where they might be stored. Without giving away the answer, I think this question will make a lot more sense to our listeners by the end of our discussion.
Exactly. Now, let's start with the basics. Victor, could you give us a high-level overview of what the stack and heap are in the context of JVM memory management?
Sure thing, Sheila. At a high level, both the stack and heap are regions of memory that the JVM uses to store data during program execution. The stack is like a stack of plates. It's a last-in, first-out, LIFO data structure that stores method invocations and local variables. The heap, on the other hand, is more like a big, unorganized closet where objects are stored.
That's a great explanation, Victor. So, if I understand correctly, the stack is more structured and the heap is more flexible. Can you elaborate on how data is allocated and deallocated in each?
Absolutely. In the stack, memory allocation and deallocation are automatic and very fast. When a method is called, a new frame is pushed onto the stack, containing local variables and partial results. When the method returns, the frame is popped off, automatically freeing that memory. The heap, however, is used for dynamic memory allocation. When you create an object using new, it goes on the heap. The heap is managed by the garbage collector, which automatically frees memory that's no longer being used.
That's fascinating. It sounds like the stack is more efficient for certain types of data. Can you give us some examples of what typically goes on the stack versus the heap?
Certainly. On the stack, you'll find 1. Primitive values that are local variables, like int, float, boolean. 2. References to objects that are on the heap. And 3. Method parameters. On the heap, you'll find 1. Objects, instances of classes. 2. Arrays, even if they contain primitive types. And 3. Class variables, static variables.
I see. So, going back to our quiz question, the int x armor5 would be on the stack because it's a primitive local variable, and new array list would be on the heap because it's an object. Is that correct?
You're on the right track, Sheila. But let's not spoil the quiz answer just yet. We'll confirm that at the end of the episode.
Fair enough. Now, I've heard that the stack is thread-specific while the heap is shared. Can you explain what that means and why it's important?
Great question. Each thread in a Java application has its own stack, but all threads share the same heap. This has important implications for concurrency and memory usage. Because each thread has its own stack, local variables are inherently thread-safe. You don't have to worry about other threads accessing or modifying them. The heap, being shared, is where thread synchronization becomes crucial. Multiple threads can access the same objects on the heap, potentially leading to race conditions if not properly managed.
That's really interesting. It seems like understanding this difference is crucial for writing efficient, thread-safe code. Are there any common pitfalls or misconceptions about stack versus heap that developers should be aware of?
Absolutely, Sheila. One common misconception is that the stack is always faster than the heap. While stack allocation is generally faster, modern JVMs have highly optimized heap management, so the difference isn't always significant. Another pitfall is assuming that all objects go on the heap. With optimizations like escape analysis, the JVM can sometimes allocate objects on the stack if they don't escape the method. Lastly, developers sometimes forget that while stack memory is automatically managed, it's limited. Recursive methods with deep call stacks can cause a stack overflow error if they're not careful.
Those are great points, Victor. It really highlights the complexity behind these seemingly simple concepts. Now, as we're nearing the end of our episode, could you share a fun fact or interesting anecdote about stack and heap?
Sure, here's a fun one. The terms stack and heap actually come from way back in the early days of computing. Stack comes from the stack of plates analogy we mentioned earlier. Heap, believe it or not, comes from heap data structure in computer science, which is often used to implement priority queues. However, the JVM's heap doesn't necessarily use a heap data structure internally.
That's fascinating. It's always interesting to see how terminology evolves. Now, let's wrap up by revealing the answer to our quiz question. Victor, would you like to do the honors?
Of course. In the question, where is the variable int x mabara5 stored, and where is the object new array list stored, the answer is int x mabara5 is stored on the stack because it's a primitive local variable. The new array list object itself is stored on the heap, but the reference to it would be stored on the stack if it's a local variable.
Thank you, Victor. To summarize today's episode, 1. The stack is used for static memory allocation and is LIFO, last in, first out. 2. The heap is used for dynamic memory allocation. 3. Primitive local variables go on the stack. Objects go on the heap. 4. Each thread has its own stack, but all threads share the heap. 5. Understanding stack versus heap is crucial for efficient memory management and thread-safe programming. In our next episode, we'll be discussing the object lifecycle, which builds on what we've learned today. Thank you for listening to JVM Internals Crashcasts. If you enjoyed this episode, please subscribe and leave us a rating. Your support helps us continue to demystify the JVM for developers everywhere. Until next time, keep on coding.